Okay, so we're going to do what we call horizontal and vertical lines. So if you had attempted to graph these, you may have seen that happen. So when you have horizontal and vertical lines, you cannot use X and Y intercepts necessarily because they will only have an X intercept or just a Y intercept for the most part, unless they just happen to fall on an axis. So they're not great ones when you have horizontal and vertical lines to use that method. But we need to be able to know what these lines are. We kind of talked about it already when we talked about axes. So we want to use the chart to help us graph y equals 2. So I'm not sure what points you picked, but we'll just pick some random points. So we got y equals 2. So I left 0 in here. That means if x was 0, well, the only thing that y can be would be 2. If x is -5, the only choice I have for y is 2. If x is, say, 3, the only choice I have for y, once again, is 2. So what you're going to be noticing here is no matter what my x is, y always has to stay 2. So if I have -5, 2 is here. 0, 2 is here, and that's one of my intercepts. So in this case, that is your y-intercept. And then we have 3, 2. Okay. So yeah, we didn't need all those lines, but this will demonstrate nicely for us that what we get here is a horizontal line. So we have certain equations, usually anything that's y equals will provide us with a horizontal line. If I asked you for y equals -3, what we'd end up with is we know that that's going to be a horizontal line here. We also mentioned earlier that when you talked about your, sorry, I'm trying to get a new color here. When we talked about your x-axis here, which is this line, well, all along this, we see that when we look at y stays 0. So that's why we sometimes refer to the x-axis. Sometimes instead you'll see it just called this line, oops, sorry, y equals 0. So when you have horizontal lines, that means you're just going to have a y equals of some sort, and everything's going to equal whatever that, or everything's, your y points are all going to equal whatever y is. So it always makes us a horizontal line. We look at our next part here. So 12, we want to use that chart again, but this time we have x is equal to 2. So it's a very similar idea. We got x is equal to 2, which means if we pick points for y, if y is 0, well, x has no choice but be 2. If y is -2, x has no choice but to be 2. If y is -5, x has no choice but to be 2. Oops, sorry. So what we have here is we had this point, 2 and -5. Forgot to write them in here. You got this point here at 2, 0. And what was my other one? 2, -2. We have that point there. Make this continuous line going through all 3 points. What we're going to see here is that we get a vertical line. So vertical lines are always something where you have x equals a number. If I had x was equal to -3, then that would be this line over here. I just have to make sure I pass through x equals -3. And then once again, we had brought this up with the axes. If you talk about your y-axis, all along your y-axis, every point here is going to have your x-coordinate is always going to be 0. Like this number right here, that's 0, 3. So because all your x's are 0, your y-axis is sometimes just referred to as x equals 0. So let's bring this all together. So horizontal and vertical lines, the graph of y equals b, or fx equals b if you're using function notation, is a horizontal line with a y-intercept at 0b. It is the graph of a constant function with a slope of 0. So those always have slopes of 0. I'd say ignore this part right now. But anytime you have y equals b, as a horizontal line, we know it's going to intercept the y-axis. The y-axis is going to have a y-intercept. The slope is going to be 0. If you have a graph of a equals a, so we're not going to talk about functions for this one, this is going to be a vertical line. And this is going to go through a point that is going to be a0. Or in our case, it's going to be a x-intercept. The slope is not defined, and it's not going to be the graph of a function. So we will see a little bit more on that. But remember, the slope is not defined. It's not that the slope doesn't exist, it's that the slope is undefined. So I always try to make this point here. Being undefined doesn't mean it doesn't exist. It means we just don't know how to talk about it. Slope exists. It is just equal to 0, or we say it's undefined. So like I said, all that undefined means is that we don't know how to represent it. We don't know what to say the value is. In this case, because it's a vertical line, if you're trying to figure out slope, you don't have any horizontal change, you just have all vertical change. So technically you have like a slope that's heading towards infinity. We don't know how to talk about that, therefore we can't define it.